Welcome to Mr. Strauss's Chemistry Corner Season 6. Will Mr. Strauss's students finally understand quantum mechanics? Will the electrons and protons finally give in to their attraction to form an atom? We'll find out. Join us for the next season of Mr. Strauss's Chemistry Corner. And once again, Mr. Strauss's Chemistry Corner was filmed before a live audience. No laugh track was used at any point during this video. All right. So, significant figures. So I got this little cartoon, which I think kind of lays the groundwork for why significant figures are important. So this little cartoon here, Kateri says that the budget for education was cut $10 million. Is that a big percentage? Does it make a difference? Congress considered a music safety law after studies showed a 10% increase in piano-related deaths. Holy cow. How does that compare to other health risks? Should I be concerned? Lawmakers debated a bill to lower the capital gains tax rate. What do other economists think? Would it stimulate the economy much? Should I care? And a new poll shows that many voters have strong opinions on these issues despite the fact that we provide no useful contextual data. And then he says, I gotta stop watching scary shows right before bedtime. So, the point of this cartoon is that we get bombarded with data. Okay? 3 out of 5 dentists recommend Crest over something else. Well, is that a big percentage? Who are these dentists? You know, how do they pick them? If you text and drive, you have a 3 times greater likelihood of causing an accident. Well, what's my likelihood of causing an accident? If I have a 10% chance of causing an accident, and texting and driving is 3 times as likely, then I have a 30% increase of risk. That's big, okay? But if drinking caffeine doubles my risk of cancer, well, what's my risk of cancer? If my risk is 0.1% and drinking caffeine doubles it, now it's up to 0.2. I'm gonna keep drinking caffeine. So I'll take the risk. So, by the way, I just made those stats up. Okay. The point is, when you hear numbers, you can't just accept them. You got to dive a little bit deeper. And significant figures helps you do that. Significant figures, or significant digits, either way, is all the measurements you are certain of plus one guess. So all the measurements you are certain of plus one guess. So I am going to give you a ruler, and I'm going to teach you how to measure, Josh, how to use a ruler. You think you know how? Yeah, you actually know. So, take one. All right, so this is a ruler, and it has 4 sides. And on this side, this is a meter stick, and on this side, there are no graduates. Okay, graduates are lines, Christian. Okay, those are graduates. So this side is not very useful because there are no graduates. So we are going to use a side that does have graduates. These graduates are to the decimeter. So 1, 2, 3, 4, 5, 6, so on forth, decimeters. Now what I'd like you to do here, Ian, is I want you to measure the width of your desk. Okay? Now, when you guys measure the width of your desk, make sure you get the ruler all the way to the edge, and we're going to use the decimeter side. So go ahead and measure the width of your desk. Nope, that's way. This way. This way. All right, using the decimeter side, what is the width, Matt?
6 decimeter.
Oh, what do you think, Sarah?
6.
Okay. What do you think, Natalie?
6.
Okay. So we're seeing a trend here. 6, 6, 6. Now, I want you to look closer, because if you look very closely, you will see that it is slightly more than 6, isn't it? Everybody, if you get it right up against the edge. Does everybody in the room agree that it's at least 6?
Yes.
Yes. That's what we would call a certain measurement. Everybody is sure that it's at least 6. Okay? Now, looking at the measurement again, what do you think the width is, Katie?
6.1 or 2.
Which one do you want? Okay. What do you think it is, Bethany?
6.1.
Okay. What do you think it is, Jackson?
6.1.
Okay. So now we have a little disagreement going on. Everybody agrees it's at least 6, but it's now in the 10th place where there's a little disagreement. We would say that this number we are certain about. Everybody knows it's a 6, but this number is a guess. Okay? You were guessing. Now, according to the rules of significant figures, you can do that. Significant figures are all the measurements you are sure of plus one guess. So this is 2 significant figures. 2, 2. Yep, Megan. Yep, those are your packets to write out and enjoy. So you are all the numbers you are sure of plus one guess. You are only allowed one guess. Okay? So 2 significant figures is good, but to increase your accuracy, you want to increase your graduates. Okay? By increasing the graduates, we can make it more accurate measurement. Now, you are only allowed one guess, and your guess is one place out. So what do I mean by that, Matt? If your graduates go to the ones place, so 1, 2, 3, 4. If the graduates go to the ones place, you get to guess to the tenths. If your graduates are every 10th, then you get to guess out to the 100th. If your graduates are every 100th, then you get to guess out to the thousandths. And if your graduates are already thousandths, you get to guess out to the 10,000ths. So you always get to guess one place beyond what your graduates are. So let's try measuring the width one more time, now using the centimeter side. So this side is in centimeters. This is in decimeters. This side is in centimeters. And the centimeters are going up by ones, right? 10, 11, 12, 13, 14, 15. Okay, Kyla, what's the width?
6.09. Oh. 6.09. Wait, what did it
In centimeters. Yeah, be
60.09.
So you think it's 60 centimeters, right? Is it between 60 and 61? Okay, so 60.9. So they're sure it's at least 60. The 9 is their guess. What do you guys think, Bailey?
60.7.
So they are sure of these two. Where is the guess? So all the numbers you are sure of plus one guess. And so it doesn't matter if you're here in the United States or in Poland or in India or in Germany or wherever you are in the world, anybody can look at this number and know, okay, these two numbers we're sure about. There's no doubt. The width is 60 centimeters. This number, not so sure about. We now have three significant figures. We've increased our accuracy, okay? So again, these are all the numbers you are sure of. That's the guess, okay? That's what a significant figure is. So I'm going to collect the rulers back, and I would like you guys to take a look at, I think it's the second page. Do some more. So if we take a look at the second line here, what would you say is letter B? Abby, what's the measurement for letter B?
57.2.
57.2. Does everybody agree it's more than 57? You bet. Those are the numbers we're sure of. The 0.2, that's a guess, right? You could even hear it in her voice. She's like 57.2. Okay, it's a guess. She's not sure about it. The graduates go by ones, so she's allowed to guess to the 10th. She can't give you two guesses. You can't do that. That's not allowed. You're only allowed one guess. What do you think letter D is, Taylor? 0.7. So the 5-0 we're sure about. The 7 is the guess. Now what if you want to guess exactly on a number, like letter H? Here I would say 54, and if I think it's exactly 54, I would say 54.0. You always have to have a guess. So if the graduates go up by 1, you still have to guess out to the 10th place. Any questions so far? I hate to admit it, but sig figs are probably the driest and the most boring topic of chemistry, and we cover it first. Okay, everybody wants to get into chemical reactions and blow stuff up, but that doesn't come until the end of October. All right, what if we are, now our graduates go by the 10th? So what about, let's say, letter B down here? What do you think that one is, Miranda? So the same principles hold true. Does everybody agree it's greater than 32.7? Yeah, we all agree it's greater than 32.7. So these three numbers we're sure about. It's that 1 that's the guess. So all the numbers you are sure of plus 1 guess. So this is a total of 4 sig figs, Jared. How about letter G, Kaylee?
26.08.
So does everybody agree it's greater than 26.0? It's not 26.1. It's somewhere between 26.0 and 26.1. So the 8 is Kaylee's guess. Those numbers we're sure about. Now what if you think it's right on a digit? Same thing like we did up there. If you think it's right on, you still have to guess out to the hundredths. So for letter F, I might guess 29.70. So those numbers I'm sure of. The 0 is my guess, but I'm still guessing out to the hundredths. Okay, how about graduated cylinders? You turn the page. The same principle holds true. If the markings go up by the ones place, you guess out to the tenths, okay? So you always measure from the bottom of the meniscus. So I happen to think it's exactly 56. So it'd be 56.0. If it was like this, that'd be 51, 52. It's between 52 and 53, so I might say 52.4. So if the graduates go up by ones, you guess to the tenths. Now, sometimes a graduate will go up by like 0.5, like this one does. So your graduates have to go up by ones in order to guess to the tenths. And if it goes up by every tenth, then you can guess out to the hundredth. Is this going up by 0.1? No. It has to go up by 0.1 in order to be able to guess out to the hundredths. Since it's going up by jumps of 0.5, we still guess out to the tenths. And that's where it kind of gets confusing with graduates, in that you have to have each tenth in order to be able to guess out to the hundredths. So if it's jumping, you're really not going out by the tenths. So you still have to guess out to the tenths place. You're not allowed to guess out to the hundredths. Okay? So there is no homework this weekend. Enjoy one of the rare weekends without homework. And then Monday we will tackle more significant figures. Until next time, Mr. Strauss signing out. So with graduated cylinders, the rules hold the same. Just to review them, Peter, whatever the graduates go up by, you can guess to the next place. Okay? So if your graduated cylinder goes up by hundreds, 100, 200, 300, 400, 500, 600, 700, then Ian, you would guess out to the tens place. So I'm guessing I got 580 milliliters, so you guess to the tens. If the graduates go up by tens, Kyla, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, then you guess out to the ones. So you might guess that I've got 112 milliliters. I'm guessing to the ones place. But if your graduated cylinder goes up by ones, so that's 50, 51, 52, 53, 54, 55. If they go up by ones, then you guess out to the tenth place. So that's why with this graduated cylinder here, that's 53, and that's 54. And so we know that the meniscus is between 54 and 53. So then, Laurel, we guess out to the tenths. And so that's why in this picture here, the 5 is our guess. We're guessing out to the tenths. And the 5 and the 3 we're sure about. So we have a total of 3 sig figs. So same thing occurs in this first graduated cylinder, Bailey. They're going up by ones. 51, 52, 53, 54, 55, 56. So if it's going up by ones, you must guess to the tenths. So if you think that it's right on the money there, Bethany, and you think it's 56, you still have to guess out to the tenths. So it becomes 56.0. That's the guess. Those we're sure about. 3 sig figs. Now sometimes graduated cylinders go up by 0.5, like they did down here. If you're gonna guess out to the tenths, you must go up by ones. If you want to guess out to the hundredths, it must go up by 0.1. So either you got to go up by 1 or 0.1. If you're going up by 0.5, 0.5 is not going up by tenths. You're going up by half steps. So basically what you have to do is, if I drew this kind of more like a scale, like 10, 1, 0.1. If you go up by tens, you guess to the ones. If you go up by 1, you guess to the tenths. But 0.5 is in the middle here. So it's still considered going up by ones. So that means you guess to the tenth. So if you're going up by half steps, if you're going up by 0.5, you would still guess out to the tenth. So that's why in this graduated cylinder down here, it says that there's our meniscus. We would still guess out to the tenths place, because basically you know it's between 42.5 and you know it's between 43.5. So you know it's between 42 and 43 is basically what you know. So then you guess out to the tenths. That's still a yes. So let's see then if you guys can read a graduated cylinder. If you flip a couple pages in, you'll see these three cylinders, 10, 11, and 12. Let's take a look at number 11 here first. Jared, what would you say the volume is for number 11, Jared?
95.
What are the graduates? What are the lines going up by?
1.
1. So there's 90, 91, 92, 93. That's 95. That's 96. That's 94. So if they're going up by ones, where do we guess out to? So 95.0, because Jared's guessing it's exactly 95. So that would be our guess. Those numbers we're certain about. We have a total of 3 sig figs. Yes, honey.
Are you always going to be certain of the first number, or could someone be like, oh, what if it's 94.9?
We'll start doing the rules, but the last digit, the last significant figure is always the guess,
Mm-hmm.
and then the rest of the numbers, the rest of the significant digits will be certain.
Okay, so there's not like a different way to interpret it. It would always be like, if you looked at that, it has to be 95, or else it's.
No, you could interpret it as 94.9.
Mm-hmm.
Then the 9 would be your guess, and the 9 and the 4 you'd be certain about.
Okay.
How about number 12 there, Krieger?
55.
Because it goes up by ones, you have to guess out to the 10th. So there's the guess, there they're sure about. Now 10's a little tricky because it's going up by 0.5. it's gotta go up by tenths in order to guess out to the hundredths. So because it's not going up by tenths, it's really going up by ones. So it's like 80, 81, 82, 83. So we know it's between 81 and 82. So what would you make a guess there, Taylor? 81.5. So the 0.5 is the guess. And the 81 we're sure. Okay, so let's go through now the rules of significant figures. Again, I just want to remind you, the point of significant figures is so that when you take a measurement, you have a way to communicate to somebody which numbers you're sure about, which numbers are guesses. So if I was writing a research paper and I said I've got 95.0 milliliters, then I would know that that 0.0 is a guess and I'm certain about the 9 and the 5. Just like if I told you that worldwide temperatures are going up 2.2 degrees centigrade. Which number am I guessing about? Well, let's make it like this, 2.3 degrees centigrade. So worldwide temperatures are going up 2.3 centigrade per year. What is the guess?
3.
The 0.3. So I might be off here, but I'm not off there. I'm certain that every year the global temperature is going up by 2 degrees centigrade. It might be 2.2, might be 2.4, but it's at least 2 degrees centigrade a year. By the way, I just made that number up, Mitchell. It's not going up by 2 degrees a year, okay? That would be huge, because that would be about 4 degrees Fahrenheit a year. So that'd be pretty intense. So thankfully it's not going up that fast. All right. So what I'm going to do is I'm going to refer to the rules, and then I'm going to do examples on another piece of paper. So it's up to you if you want to rewrite the rule